Hello and welcome to the second lecture of the on the Pythonic notebook. In this video, we'll be talking about imports of Python modules and packages. So you've already seen many times by now this import syntax. It's at the top of every notebook we've shown you so far. We're importing a couple of plotting libraries to standardize the appearance of any graphics we might create in any of our notebooks. We used it earlier in this notebook with import this. What do these import statements do? They allow us to augment the built-in functions and objects in the Python interpreter with additional variables, objects, class definitions, function definitions, basically additional code that is stored in other files. So when we import a module, the Python interpreter reads a Python file and executes code in that file defining anything. It runs the file basically. So if there are class definitions in the file, it will run those class definitions. If there are function definitions, it runs those function definitions. And so we can gain access to a lot of new objects and functions and that sort of thing by importing modules. So for instance, we might import pandas if we want to gain access to the pandas data frame object to give ourselves a table-like data structure. And we'll make use of pandas later in the course. Packages are installed and managed by package managers. There are two main package managers in use for Python. Conda, which is the newer package manager, which also provides management of virtual environments, and pip, which is the older package manager that does not include virtual environment management. We're not going to be talking about virtual environments today, but that's the main difference between these two. And there are efforts today like pipenv for adding environment management to pip. We also won't be making use of package managers during the course. We've already installed all the packages you need, but just for your own education, and if you are working with Python on your personal machine outside of the course, it's useful to know about these package managers. So we can import pandas, and we see if we evaluate pandas, we find that it's a module, and the module comes from this file. So packages are stored in a special directory called site packages, and the structure of packages typically will have many .py files, but there will be one called dunder init, similar to the init method of a Python class. And this file specifies the instructions for loading the entire package. If we, for instance, look at the folder where that file lives, we see there's several py files: conftest, version.py, parser.py, tslib.py, lib.py, json.py, and then many of these subfolders also contain more .py files. And this init .py contains instructions for importing the entire package and making it available under the correct namespace, which I'll describe in a moment. But we can see there's more import statements in this init, importing these various other .py files and adding them to the namespace. When we're importing a package, often we'll see this pattern: import package as a alias. And this is to save us typing. We see it does PD evaluates the exact same thing as pandas. But now anytime we want to use something from the pandas package, instead of saying, pandas.dataframe, we could do pd.dataframe. And this saves us some typing. A lot of the aliases are conventional, meaning the community uses the same alias for particular packages. So pandas is almost always aliased as PD. NumPy is almost always aliased as NP, etc. There's a handful of these standard aliases out there, and as we encounter them, I will point them out. So we can import .py files, which are called modules, to supplement the built-in Python interpreter with additional Python code. And we can give those modules aliases, which brings us to the idea of namespaces. So a namespace is related to the idea of scope. Scope, you may remember, is the space under which an object is defined. It's the extent under which an object is defined. So for instance, if I make my var for my variable, that's in the global scope. My interpreter knows about this my var at the highest level accessible. I can therefore use it in functions where my var is not defined within the function. My var is defined in the global scope, so this function is aware of it even though it's not defined within the function. It's not defined as an argument, it's not defined in the body of the function. So this function falls back to the global scope and finds my var and returns it as 25. This is in contrast to, I could define another function with an argument my var, and if I pass in 26 for my var, it returns 26. So here my var is defined within the scope of this function here as an argument, and so the function knows what this my var means. It's this one here. It doesn't look for my var in the global scope because it's defined in the local scope of this function. So related to this idea is the idea of namespaces. Namespaces are a way of organizing the scope of various names in our interpreter. So, for example, currently there is a pd.dataframe object or class. So I could create a data frame. And we'll talk more about data frames in the future, but they look like this. And this data frame class lives under the PD namespace. Just like before with my var, I could also have a data frame class where I can give it any definition I want, and it does something very different from what the pd.dataframe does, because these are two different classes. Data frame in the global namespace versus data frame in the PD namespace. So namespaces are this sort of hierarchy of scopes, if you will, where we organize the various names in our interpreter. So this is very helpful because, for instance, we might want to parse some data files into the interpreter. When we do that, we might want different parsers for different types of files. Now, I could define, for instance, something like experiment, or we'll say, what should we say? User parser for parsing in user data from some text records. And this does something. And then I could have like a record parser does something else. And I could have all these different parsers. Oh, actually, let me do this slightly differently. So I could have, we'll do this a little bit differently. So I could have different functions. Parse user. And this would get something like, text. Parse the text. Return user. And here I have like, user equals user blah. So we'll have a class called user that represents user data in some way. Name. This should be self. Username. Password. And then we could also have a, say, record object that gets created when users do something. So, we have a message board, and there's lots of activity. People make comments, people post questions, that sort of thing. So we might say post type text. So this stores like whether they made a question or a comment, and then this stores the text of that question or comment. And we could have parse user functions that parse some text in some way, and then creates a user object. We could have a parse record that also parses text and creates some kind of record object from what we parsed out of that text. But as the number of different kinds of objects we're working with expands, we're going to end up with a bunch of these different parsing functions, and our namespace is just going to get a little cluttered. And it might be difficult to remember what things are named. Parse record. Okay, is that like referring to posts or to votes, like upvotes and downvotes, or whether or not an answer was selected? Record is like a very generic term. And I might be able to make a more specific name But at the end of the day, we're going to end up with a bunch of these parsing functions, all with different names, and we're going to have to remember how they're named, if not what they're named. So another thing we could do to keep our namespace organized is each of these classes could have a parse method. And it would do the exact same thing as these functions I defined below. But now, since the parsing methods are attached to these classes, we don't now need to remember what the parse method is called. We don't need to remember that it's parse user or parse record. Just every object or every class will have a parse method that I can call. And now, the reason this is called a namespace is because I can do something like user.parse or record.parse. And I have the same name, parse, but they will do different things for the different classes. And the names are kept distinct based on which class they are attached to, user or record. So this is a really useful idea. It maybe seems sort of unnecessary or silly at this point, since we're writing pretty simple programs and don't have to keep track of very many overlapping functions as we're, say, working on the mini projects or working through the lectures. But in more complicated applications, this idea becomes really crucial to prevent too much clutter in the names and to help us organize our various objects and functions. Note, if I had not defined this other data frame object, I would get a name error here. I won't, because I defined a data frame object in the global namespace. So I'm just going to edit this real quick. So Pandas also has a series class that we could access with pd.series. We see that here. Pandas core series. So there's this series class in the Pandas namespace. But if I were to try and access series as part of the global namespace, I would hit a name error because series is not defined in the global scope. There is no name series in the global namespace. It's only in the Pandas namespace where series has meaning. So you can think of a namespace as the domain over which a name has meaning. And for example, my name is Dylan. My sister calls me Pookie. If that name wouldn't have any meaning to you or to many of my friends, if they heard me called Pookie, they would not know who is being referred to. That name is not part of their namespace. However, it's part of my sister's namespace. If someone calls me that in front of her, say my mom, then she'll understand what that means. We can not only import packages or modules, but we can also import parts of packages. So often we might do something like from pandas import data frame if we don't need the entire pandas library, but just want a particular class or function out of it. So you might see things like this, and we see that it returns for us the same object, pandas core frame data frame, as pd or pandas.dataframe. So if we're trying to keep our namespace light, then we might import just a part of a module. We can import everything from a module using from module import star, but it's very discouraged to do this because it's very common that there will be multiple functions or classes with the same name in your module as built into Python or from other modules. So again, here's where namespaces come in. NumPy, for instance, has a sum method. Pandas also has a sum method. Additionally, there is a sum method built into Python. If I, from pandas, import star, the built-in sum function is going to get overwritten by the pandas sum function, and this can cause me problems. So namespaces are really helpful in keeping those overlapping names distinct by putting them under a hierarchy of module names or class names. The final thing I want to mention, actually I want to mention a couple more things. I said that when we import, I mentioned when we import a module, what the interpreter is doing is it's going to this file, this py file, and it's running it. It's just running all the code in here, which is generally true. There is one exception to that statement. So I got a question today in the office hours about something that shows up in a lot of HackerRank challenges. So in a lot of HackerRank challenges, you'll see a block of code that begins with if name equals main. And this code is not run when we import a .py file as a module. All of this code above it will be run. This code, so Python files essentially have two purposes. One, they function as modules that can be imported into the interpreter to give us access to additional functions, classes, and constants. Additionally, Python files work as scripts, as programs that can be executed to perform particular tasks. The portion of the file that represents essentially the module is at the top. At the bottom, we will have the portion that represents how this file should be run as a script. And that portion always begins with if name equals main. And then we have code that will only be run when we run the file from the command line as a script. It will not be run when we import it as a module. So at the top, we get any import statements for dependencies. We get any function definitions, any class definitions that we might want access to when importing this file as a module. At the bottom is the script functionality. For instance, let me see if I can find you an example on your server. Really? No? Okay. I will go to my GitHub. And pull an example that I worked on. So I play some. I play Dungeons and Dragons, for instance, and when I want to name characters from different parts of the world, I like to be able to generate random names from all different regions of the world. So, this is not actually an example of what I was going to show. I will have to go to another example. Okay, let's choose this one. So in New York, where I live, they have been doing maintenance on one of the trains. And a friend of mine was interested in what the impact would be on people's ability to get around the city. He wrote code to use a website that would scrape a website and generate some plots of travel times with and without this train. So he has all kinds of functions defined to help him do this, as well as some constants. And at the bottom is this if name equals main block, where he actually samples from the website many different travel routes around the city using this train and not using this train. And what he would do is, let's try git clone. What he would do is something like run Python sample API, and this would run as a script. And it didn't work for me because I don't have all the required packages installed, like I don't have GeoPandas. But after running all of this code up top, it would then run this block at the bottom. So when there is a special name variable in Python that gets set when we access a Python file. And if we're importing a file, it gets set to the name of the module. But if we were to run this file from the command line, this name variable would get set to main, and so the Python interpreter would run all this code. So here we just define how this file should run as a script if we run it from the command line using the Python interpreter. There's a set of packages that we use very frequently in Python that are pre-packaged with the interpreter, and basically any distribution of Python will have these packages. It's called the standard library, and there is documentation about what they do, what kind of objects are available. We've already seen the collections module from the standard library and talked about things like counter, named tuple. But there's quite a few packages in the standard library for doing things like representing dates and times, interacting with the operating system, working with compressed files, as we'll be doing in another lecture in this week. All sorts of things that are very commonly used in a wide variety of Python projects. So it's useful to know that even without any additional packages installed, we have access to quite a few modules that extend what is built into the interpreter and allows us to do quite a few interesting and complex tasks. So I'm going to stop the video here, and in the next video we're going to move into another topic advertised at the beginning of these lectures about error messages and debugging.